Dear viewers, welcome to another video in our playlist of time series list of videos. In some of our previous videos, I've explained about the concept of correlation, which is a statistical relationship between two sets of variables. And then we also had another video where I was explaining about autocorrelation, which is a relationship of a variable with a lag of certain number of data points on the same time series, where I have explained about how temperature of Chennai on day 1, 2, 3 can have an impact on the temperature of Chennai on day 4. So this is called autocorrelation. Same data in a time series can have an impact after a lag of certain number of data points, and that lag can be 1 or 2 or 3 data points. So this is the concept of correlation and autocorrelation. However, in today's video, we are going to have an understanding called cross correlation, which is a combination of both these concepts, a combination of correlation as well as autocorrelation with a lag. So as a combination of these two, we are going to understand something called cross correlation. Let's get into the video. As I was explaining in the introduction, cross correlation is actually a combination of two concepts. Correlation will give you the relationship between two set of variables, and autocorrelation will give you the relationship between a time series data with certain number of lags. When you combine these two, you get cross correlation. Let's understand what it is. First, let's go through the definition. So cross correlation measures the similarity between two time series as a function of the lag between them. It helps determine how one series influence or is related to another over a time. So what do we mean by this? Let's take one example to understand this better. So if you want to study the relationship between temperature, which is your variable A, and how much ice cream gets sold in a city, which is your variable B, and you want to understand the relationship, what you need to understand is today's temperature may not directly impact the sales of ice cream today. People will feel warm, hot, so it's good to go and have ice cream, but not necessarily today's temperature will have impact in sales of ice cream today itself. What it will do is it will have the impact of sales of ice cream maybe tomorrow or day after tomorrow. There will be a lag. Not immediately people will react to increase in temperature. So today temperature increases, not necessarily I have to go and buy ice cream today. I may go and buy ice cream tomorrow or day after tomorrow. So this is what we call it as lag. So your parameter A, which is temperature, is definitely going to have impact on sales of ice cream, but not on same time period. On day 1 temperature increases, not necessarily on day 1 you will have your sales of ice cream also increased. Your sales of ice cream can have a lag of 1 day or 2 days. So the correlation cannot be compared between time period 1 and time period 1 between your A and B. Instead, it need to be compared between time period 1 for parameter A and time period 1 plus 1, which is a lag of 1, or time period 1 plus 2, which is a lag of 2, and then you need to compare the correlation. So this correlation with certain amount of lag is what we call it as cross correlation. So this cross correlation can be measured statistically. How do we do it? Let's get into the formula. So if you see the formula here, the formula for cross correlation function CCF with a certain amount of lag, and that lag can be 1 data point, 2 data point, 3 data point on the positive side, and the lag could also be on the negative side. At that stage it will not be called a lag, it will be called a leading factor. So that's what we call it as minus. So you can also have your lag as positive 1, 2, 3. Your lag can also be negative 1, 2, 3. So the formula here says you need to find the difference between the parameter on time period 1 and its average, the parameter on time period 1 plus the certain amount of lag, or 1 minus the lag, and then you need to find the difference with the average, and then the denominator will be the square root of squared deviations. So that is what we have here, square root of squared deviations. Don't get intimidated by the length or the size of the formula. We will try and simplify it as easy as possible. Let's get into the calculation to make it easy for us to understand. So here I have taken a sample data where I have taken number of hours spent by the sales team who are giving a demo for a particular software. So you book a demo call, you explain the software, and once you explain the software, you expect the people who listen to your demo or who have understood the software based on your demo to place an order to buy your software. So generally what we say, more the number of sales calls or demo calls that you do, you have more chances to sell your software. So logically, the correlation between sales calls or the number of hours you spent on sales calls should reflect on increased invoice value. So there is a natural correlation that we are expecting. So just for calculation purpose, I have taken only 5 data points. So for this 5 data points, if we try to apply the correlation function, so the normal correlation function, and in Excel we can apply CORREL, the formula, select the first set of variable and select the second set of variable, and then if we close the bracket, we get the correlation coefficient. Those who are not familiar with how this formula operates, what is the logic of correlation coefficient, we have made a detailed video explaining the concept of correlation coefficient. So we will give the link of that video in the description. So if you are not familiar with the concept of correlation, kindly listen to this video before continuing this video. Okay, now the correlation coefficient says 0.29, and we all understand correlation coefficient closer to 0 means there is no correlation. So can we conclude that, okay, the number of hours that we spend on demo call have very weak positive correlation or almost no correlation, so there is no point in spending more time in demo calls. That is not a indicator, or that's not something which will impact the order that we book. So shall we conclude it that way? If we simply go with correlation analysis, we have to do that. But however, let's apply the concept of lag. So if I give a demo today, not necessarily the invoice has to be booked today. So after today's demo, people can book invoice tomorrow also, right? So then what I need to understand is, I need to understand what could be the cross correlation. Cross correlation is, if I take the correlation not exactly for 7th of February, how much calls we have made or what is the duration of calls, and 7th of February, what is the total invoice value. If we do it for the same time period, we call it correlation. However, if we do it for a different time period, then we call it cross correlation. So we need to understand cross correlation with a lag of 1 and 2. So that means if we give a demo today, his invoice is getting booked tomorrow or day after tomorrow. So at max we can keep 2 days. So that's what we call it as lag. So how do we calculate this lag? So for us to calculate this lag, the first thing that we need to understand is, we need to understand the average of my X and Y for the given number of data points. So here I have 5 data points. So I have calculated the average of these 5 data points. So the average is calculated here, right? And once I have the average, the next thing that I need to do is, I need to find out the difference between my average and my individual X variable. So if you see here, the formula that I have written is, what is the difference between B2, which is nothing but the first data point of X, against the X bar, and then I have squared it. So if you go back and see the formula says, find the difference. I am basically now working on the denominator. Find the difference and square it for your variable A. Similarly, find the difference and square it for your variable B. So that is the data that we are working on. So what I have done, I have found the difference and I have squared it. Similarly, I have found the difference here and I have squared it. So I have computed these values, the difference, and I have squared it. And then the formula again says, after you square it, you make a summation of it. So what I do, I make a summation of these two values and I keep it with me. So finally, I need to apply the square root. We will come to the square root later on, but as of now, we have found the difference, we have squared it, and we have created a summation of it. So this part is done. Now what I need to understand, the natural correlation or the normal correlation here is 0.29. Now I need to find out the correlation with a lag of 1. What do we mean by lag of 1? That means I need to find the correlation for the first 4 data points, right? And then I need to find in my variable B, I need to take the data point 2, 3, 4 and 5. I should leave out 1. Why I am leaving out 1? Because I am finding correlation with a lag of 1. So what I do, I take those data and I arrange the data here for a better understanding. So for a better understanding, I arrange my data here. For my X and Y, I arrange the data here. Okay. So now what I have the first 4 data points for my A, and I leave out the first data point in my B and I take the next 4 data points in my B. So here is the data. Okay. Now what is my numerator formula saying? The numerator formula says once you have this data, for example, if you see this says BT means B with a time period 1 and A with a time period plus lag, H refers to lag. So we have taken the data here with the actual data and this is with the lag of 1. So I have taken this data. So once I have taken this data, then the formula says find the difference from the A bar and B bar. That means find the difference from the respective averages. So here I have found the difference between the respective averages. So what you see here will be the difference with respective averages. If you see the formula here, the formula will say the first value, which is 7.2 minus 12.74, and the second value 11.1 minus 12.74. Similarly for B also, I am measuring the same difference, the difference between the data point from its original average. So, okay. So now once I have done this, then let's go back and see what the formula says. The formula says is to create a multiplication of these two, a product of these two. So what I do, I create a product of these two values in my next column. So the product of these two individual deviations. And then again the formula says create a summation of this product. The formula says create a summation of this product. So what I do, I create a summation of this product and the summation is 103. And finally the formula says this numerator will be the summation of the product and the denominator will be the square root of these individual deviations that you have already measured and summed up. So this, what I now highlight in yellow, will become my numerator, and what I'm going to highlight in green will become my denominator. So let me make it in font white so that it becomes easy for us to understand. This will be the denominator, but before applying this as a denominator, there need to be a square root. So what I do, I come here and I create my formula. And what is my formula? My formula, if you see here, the numerator will be this column, which is N8, and the denominator will be square root of product of F8 and G8. Why square root of product of F8 and G8? If you see here, square root of product of this deviation and this deviation, and that is what we have created as a formula. And now you can understand that there is a very strong positive correlation between hours spent on call and the invoice value that get booked, but not directly one-to-one correlation, but cross correlation with a lag of 1. So this is what we are explaining as cross correlation. So if we don't understand the concept of cross correlation, we may simply conclude hours spent on demo call has nothing to do with how much invoice get booked. So let's not focus on giving more and more demos, but actually in a software industry, giving more and more demo will help us generate more and more customers and get more and more invoice booked. So that is getting explained here with a lag of 1. Now you may ask, is it necessary that the invoice should get booked on day 1 itself? Don't you think the invoice can be booked on day 2 also? If you have the doubt, then we can calculate the same cross correlation for a lag of 2. So here we have calculated it for a lag of 1. Now just for our understanding, let's calculate it for a lag of 2. So what I have done, I have taken data points 7.2, 11.1, 21.3, the first 3 data points. Then on the B, I have taken data point 15.3, 25.4 and 15.8. Basically what I have done, I have taken with a lag of 2. Earlier I have taken with a lag of 1. Now I am taking with a lag of 2. Now what should I do? I should repeat the same formula that I have done, which is nothing but I need to calculate the difference, because this is 7.2. So how much is this data point away from its average, right? So the difference is getting calculated here. So for our understanding, the difference is getting calculated here. The difference between the data point from its average for both A as well as B. And once I have the difference, again the formula says create a product of the difference. And after creating a product, you create a summation of the difference. So the summation here is minus 12.69. So that is a summation. Once I create the product, minus 12.69 is my summation. Now what I do, I can calculate lag of 2. How I can calculate lag of 2? Again, the denominator is still going to be the same, which is nothing but square root of product of these two values, but the numerator will be my summation of this product which is created by a lag of 2. And now if you see, the correlation is minus 0.1, very, very weak or no correlation at all. So then what I can conclude in this analysis is, if I make a demo call, there's a strong positive correlation that the demo call could result into a invoice booking on T plus 1 day with a lag of 1 day. In some cases, we may even analyze a negative lag. Negative lag is basically when your change can happen in a negative way. So negative way, how change can happen? For example, I want to understand the relationship between, so let me take this data. I want to understand the relationship with a lag of minus 1. What do we mean by lag of minus 1? Let's understand that here. So lag of minus 1 means I have 11.1. That means I am taking the second, third and fourth data point in my column A, and I have first to 4 data point, 9.3 to 25.4, slightly different from how we have taken a lag. Here lag is plus 1, here lag is minus 1. So once I take the lag minus 1, so I take the second to fifth data point in my column A and first to fourth data point in my column B. Then what I do, I repeat the same analysis, which is nothing but initially we need to find the difference with respect to its averages. So if you see here, I have kept the average, and once you find this difference, then we need to make a product of this difference, and this product difference need to be then converted into a summation. So I have the summation value here. Now this is the actual correlation. This is correlation with a lag of 1 and this is correlation with a lag of 2. However, if I want to find out correlation with a lag of minus 1, then what I do, I create this formula. What is the formula? Again, the numerator is this product and then the summation value. The denominator will still be the square root of product of these two values. And what we see here, we see minus 0.25. Naturally, demo calls cannot have a negative lag with the invoice that is getting booked. That's not possible. But however, for our understanding of positive and negative lag, I have calculated these things for you to understand this better. So similarly, we can also calculate it for negative lag of minus 2 also. So simply the formula again goes in the same way. We need to get the data arranged as per the negative lag of 2. For example, here I have taken data point 3, 4 and 5, whereas on the other side I have taken data point 1, 2 and 3. So there is a negative lag, and with negative lag we repeat the same calculation, finding the difference with average, and from there finding a product of both x and y. And once we have the product of both x and y, then we create a summation value, and finally we come back and create the cross correlation function formula, which is nothing but the numerator will be the summation value and the denominator will be the square root of the product of the individual differences that we have squared already. So this is how we calculate the cross correlation function with a lag, as well as lag which can be a positive value or lag which can also be a negative value. So friends, I hope this video was useful for you to understand the concept of cross correlation. Whenever you feel that your x and y are correlated but not correlated on the same time period, there could be a lag, and that lag can be positive or negative, then you can apply cross correlation. Here I have clearly explained the formula, and in my next video I am planning to explain the same thing using Minitab. So when you are doing this analysis with Minitab, the benefit is you will be able to perform this lag positive and lag negative for a large number of lags, not only with 1 or 2. If at all you think the lag could be for 7 days, lag could be for 5 days. Sometimes there is one example which the Minitab sample data set is providing us, which is nothing but how much of a particular material present in river. For example, the river water is being taken as a sample, and how much of a material sedimentation is available in a particular water at upstream, somewhere 100 kilometers away upstream, and is that sedimentation is also visible in downstream, right? And what is the correlation? So for the water to travel 100 kilometers and reach downstream, it definitely takes some time. How much time it takes? If I really want to understand, it may not be in 2 days or 3 days, sometimes it could even take 7 days. So to understand this, we can also do a cross correlation. So that is the example that they have given in Minitab, which I am planning to explain in my next video. So when you are using softwares like Minitab, you have opportunity to perform the same cross correlation for more number of days. So when you manually do it in Excel, the calculation becomes lengthy, so you generally do it for 2 days or 3 days. but if required, you can even go up and do it for 7 days or 10 days, depending upon what is the data that you are analyzing, right? So as explained, friends, this is the concept of cross correlation, relationship between two sets of variable with a certain amount of lag. So for the next video on how to do the same analysis in Minitab, please follow our channel. And for more videos on statistics, time series analysis, and Lean Six Sigma related tools and techniques, Minitab related tools and techniques, please subscribe our channel. Thank you.